To understand the relationship between work and kinetic energy, we must understand that work equals force times distance. Kinetic energy equals 1/2 mass times velocity squared. Changing KE, or delta KE, is equal to work. Say we have Luke's car. We're going to use the mass of 10 to make terms more simple. We have Luke's car going from 0 to 5 and 5 to 10 miles per hour. KE, the change in KE equals KE final minus KE initial. Now for the first car, the KE final is 5 and the KE initial is 0, and we transfer that to meters per second because that's what the velocity is put in. So we have 1/2 times the mass, 10, times the velocity, 2.24 squared. We get 5 times 2.24 squared, 5 times 5.016, and that equals 25.088 joules. And the KE initial was, the velocity was 0, so all that's going to equal out to 0, so the change in kinetic energy from 0 to 5, or 0 to 2.24 meters per second, is 25.088 joules. Alright, so 10 to 5 is a change of 5 miles per hour, and so is 0 to 5. So should the change in kinetic energy be the same? We'll see. So using the formula, kinetic energy equals 1/2 the mass times velocity squared. The velocity for meters per second in miles per hour is 4.48, so 5 times that squared, and we get 100.352, and now we have to subtract it from KE initial, and the initial was 5, and we already calculated that in the previous problem, and we get 25.088, and we subtract these two because it's KE final minus KE initial, and we get 75.269. Wait, that is different from the other change in kinetic energy. I wonder. Okay, because change in kinetic energy equals work, well, the change in kinetic energy for 0 to 5 was about 25.088, and that equals force times distance because equals work, and work is force times distance. And so our work, our force was mass times gravity, so our mass was 10 and our gravity is going to be 10, so that's 100 times d, so 100d equals 25.088. So to get d by itself, we divide 100 and we get 0.25088 meters, and that is the stopping distance from 0 to 5 miles per hour, or 0 to 2.24 meters per second. Alright, so we do the same math again with different numbers. Okay, so change in kinetic energy equals work, 75 equals force times distance, and we get 100d again because it's the same car, so we divide that by 100 to get d, and we get 0.75, and that is equivalent to 3 times as much, about around 3 times as much as the last time.